everyone, and welcome to our webinar today. We are going to discuss about OCI functions. We have here Flavius, who is your speaker and your guided tour for this session, because we have a demo as well to show to you. I am Violeta. I'm very happy to see that so many of you joined our session today. Keep in mind that the Cloud Coaching live sessions are brought to you by Digital Customer Experience team in collaboration with our main partner in the Oracle DevRel team. We have also, in case you guys watch any of our Cloud Coaching sessions recordings in the future, keep in mind that you might see some slightly differences within the Cloud Console menu, because our products are enhanced on a regular basis. That was all on my side. Flavius, over to you.
Okay, thank you, Violeta.
You're welcome.
Good morning, good afternoon. My name is Flavius. I'm an operations advisory specialist with Oracle EMEA, and yes, I work with Oracle Functions and with many other things in OCI. And for today, I prepared a couple of slides and a demo to show you how you can use OCI Functions in order to integrate different services that we have in OCI. So I see from the pool results that many of you worked with OCI Functions in the past, and you have at least an idea of what OCI Functions are. What I will do, like I said, I will anyway go over the concepts of OCI Functions and show you a couple of very cool demos of what you can do with OCI Functions. I will share my screen now because I have prepared a couple of slides, and like I said, I have a demo to show you at the end of the presentation. So please let me know if you can see my my screen.
Yep.
Yeah. Okay.
All good.
Okay, let me hide this because it's getting in the way. So these are the objectives for today's presentation. First, I will give you an overview of OCI functions, what OCI functions are, a couple of core concepts, how you can deploy functions, how you can invoke those functions, and we'll continue about integrations with other services. You will see that OCI functions are deeply integrated with other OCI services. I'm talking here about identity and access management. Of course, you will have to define policies to control the functions, who can use functions, and what those functions that you are building can do, and also how you can integrate those with dynamic groups and with resource principles. Main features of OCI functions, the patterns that you are using to deploy and call OCI functions, and a couple of scenarios that you can use for using OCI functions to integrate different other services. So for example, if you want to send data between two services and you want to enrich the data that is passed between those two services with data from a third service, for example, you can use very easy OCI functions for that. And let me start with the beginning, the types of serverless compute that we can use right now. And this is not just for Oracle, for OCI, but for all the cloud providers, cloud services that are available right now. So first, you can use bare metal type of serverless compute, in which you have access to a full machine, to the hardware of the machine, but you will have to deploy, in this case for your application, the operating system, the hypervisor that you will probably use, and you will have to configure the hypervisor, you will have to configure the operating system, you will have to deploy after that your application. The second option that you can use is using virtual machines. So in this case, you are running these virtual machines on top of the hypervisor that is provided by the cloud platform, and you are using different images for your virtual machines, and you have, of course, complete control over the operating system, and of course, what image do you want to use for the virtual machines. The third option is to use containers, very how should I say, fashionable option right now, because everybody's using containers. So instead of running full virtual machine, an application on a single virtual machine, you can run multiple containers, applications in containers, multiple containers on the same virtual machine, and each application running in the container has the view like it's running on its own machine. And of course, there are solutions for orchestration of those containers. So there is Docker Swarm, there is Kubernetes, and you can use those to orchestrate those containers, control the life cycle of containers. The third option, and the easiest one, is using functions, and you don't have to deal with containers, you don't have to deal with virtual machines, you don't have to deal with the configuration of the operating system. You are just executing the code in a container, in the containerization way. Sorry for this, but I cannot find a better word. You are just running your code, and the code is executing the task that you want to do. That can be an integration task, that can be an enrichment of data task. You can do whatever you want within a function. And these functions are and OCI functions, of course, are driven by an open source project. It's called an FN project. It defines the standard of running these functions as a service. Each function it's executed in a container, and that container can be a Docker container or a different other type of containers. It's an open source engine for running functions, and it's multi-tenant and integrated with the Oracle Cloud. So basically, what you are doing, you are executing fragments of code in containers using this open source engine, and this code that you are executed can be integrated with the Oracle Cloud services, and it's executed in a multi-tenant fashion, so you can have hundreds of functions, thousands of functions executed at the same time. And if you're looking, for example, in the project, fnproject.io, this is the website of the project, you will see you have access to the documentation, so you have complete documentation of the project. And Oracle function, OCI functions, it's implementing this standard, this open source standard project. Now, you want to use Oracle functions. How you can do it? There are a couple of steps that you have to follow. First, you can use the SDK that is provided by the FN project, FN SDK, to generate the skeleton code for your function. And of course, you can generate that skeleton code for your function in a different programming languages. So, for example, if you are familiar with Python, you can code your function in Python. If you are familiar with Golang, you can code your function in Golang. The same for Ruby, for Java, and for different other programming languages. So you are using the tools that are provided by the FN project, the FN SDK, to generate the skeleton code for the function. Next step is to add the code that is performing the task that you want to execute, and that can be accessing a database, reading data from a stream, or writing data on a stream. You can do whatever you want, send emails, send notifications. You have full access to different services. If you want, for example, to integrate not with Oracle services, but with third-party applications, of course, you can do that. You can send data into ServiceNow, for example, or send data into Splunk. You can do that from within a function. Now, if you have the code for your function completed, next step is to build your function, and you are building this using, again, the tools that are provided by the SDK, by the FN SDK, and you are packaging your function code into a container image. That container image is pushed into a service registry, and you can use it. After that, the OCI function server can pull that image from that image registry, create a container image, and execute a function. But for that, you have to configure a trigger, so you are able to start the function execution manually, using, again, the same tools that are provided by the FN SDK, or you can use the function HTTP endpoint and make an HTTP call that will invoke your function, that will trigger the creation of your function, or you can use it directly. You can start the function as a response to an OCI event, or as a response to a message that arrives on a notification topic, on an OCI notification topic. Or you can do many other things. You can use the OCI SDK to call functions directly, or yeah, I mean, the sky is the limit. You can mix and match all these options. Now, when the function is executed, the user is billed only for the execution time and the resources that are consumed during the execution. So that means that you don't have a server that is running your code and is waiting for the request. When the request arrives, that container that you created for your function, container will be created with the image that you created for the function, and then that container will take your request, execute your code, and will wait for subsequent requests. After an interval of time, after a couple of seconds, a couple of minutes, that container will be destroyed, and the cycle repeats for each new request. So this is how Oracle functions are working. Basically, what we are providing with Oracle function is an FN functions server that is executed in a multi-tenant fashion within OCI. So, like I said, you can invoke a function using different triggers. So you can use the CLI, the tools that are available with the SDK, with FN SDK to call the function, to start the function. You can use an HTTPS call. You can integrate that with, for example, an API gateway, and I will show you how you can do that during the demo. You can use it with different other services, with events, with notifications, with different other services. And for integrations, you can integrate OCI functions with different services. So for example, if you are using, let's say, Python to write your function, you can use the Python SDK, OCI Python SDK to interact with the different other services. I'm talking here about database, compute, all the services that have that are exposed via the SDK, via the Python SDK, OCI Python SDK are available to be integrated with the functions. Like I said, you can build your functions in different programming languages. I will show you later during my demonstration a repository with a couple of examples. This is an official GitHub repository with some examples of functions written in different programming languages. But like I said, Python is a very popular choice for writing functions, Java as well, Golang. There are a lot of people who are writing functions who are using Golang programming languages, and all these options are acceptable for writing functions. And like I said, you are generating a skeleton code for your function using the preferred programming languages, and after that, it's the tools, the FN tools job to package your code in a container and make it ready to be executed by the FN server, by the function server. One thing that I want to mention here is that you have a very simple, the code that is generated is very simple. You have just a function that has a couple of attributes. In the data attribute, you will get the payload that it's used in the function invocation. So you will get in the HTTP post, for example, a JSON, and that JSON will be available using via the data attribute, and you will have also the context attribute that will get from which you can get function or application context information. Again, we will see those later in the demonstration. So this is how it looks like when you are generating the function. So you are choosing to generate a function using Python programming languages, and this is what you get when you are running that command that will create the skeleton for you. So you have just one method, the handler method, with a couple of parameters, the context and the data, and you have a couple of how shall I say lines of code that are providing you an example. So you are reading a JSON from the data attribute. You are getting a parameter from that JSON, an attribute from that JSON, and you are sending a response again formatted as JSON back to the application, back to who invoked this function. Like I said, it's very easy, and easy to understand and easy to change, easy to modify. Now, functions are not deployed by themselves. When you are deploying a function, you are actually deploying a function in the context of an application. So first, for deploying a function, you must create an application. And that's a resource that you have in OCI. You can create this application using the console, the OCI console, or you can use the services that are available, OCI services that are available, or tools, the CLI, REST API tools to create this application. And within the context of an application, you can deploy one or more functions. So when you are creating an application, you have to specify a couple of resources that are going to be used by the functions in the application. First, you will have to provide a virtual cloud network and one or more subnets. You can provide up to 3 subnets for this for an application. All those subnets must belong to the VCN that you are selecting. Now, when you are providing these subnets, when containers are going to be created for your functions, are going to get IP addresses from these subnets. And for example, if you have a private subnet that you selected here, the function will be able to integrate, will be able to call resources that are available in the same private subnet. So for example, in the same subnet, you have a database, and the function will be able to call that database to interrogate that database that is available in the same private subnet. So that's the reason for which you can provide. You have to provide a subnet, one or more subnets when you are creating a function applications. Now, within the context of an application, you can create these functions, which are, like I said, simple blocks of codes that are executed with a goal in mind. So you can use it to write data to a file in object storage. You can use it to write data to a stream. You can use it to enrich data that is provided as an input for your function and send data after that to different other services, for example, external tools, ServiceNow, Splunk, whatever. And once you have this code, it's packaged into an image and is available as a function. That image is available to be executed as a container. Of course, functions are part of the application, and very, very important, we are using Oracle registry to store the container images. And when the function is called, first, that's the first step. The FN server, the function server, will go to the Oracle registry and get the image for your function. Now, the function, like I said, it can be invoked using the command line interface or using HTTP call, but of course can be integrated with other services, events, rules, event rules, notifications, and so on. And for invocations, like I said, you can use the FN project CLI utilities, you can use the OCI SDK, you can use the HTTP function expose endpoint, and also you can integrate it with different other services, event rules, API gateway, notifications, subscriptions, and so on. And this is the lifecycle, and we will go over the lifecycle a little later because I have a nice diagram that shows the lifecycle of a function to you. Okay, a couple of words about triggers. Triggers are events that can initiate the execution of the function. So basically, a trigger is starting the function, and you can have different types of triggers. FN project supports a number of triggers. Some of those are available with Oracle Functions. Now, for the integration with other services, OCI Functions is integrated with the Oracle Identity and Access Manager, and in order to use the functions, you have to create a couple of policies first. So, for example, if you want to use the repository before you are using functions, you must create these policies in the root compartment of your tenancy that allows the service function as a service to read all the registries in your tenancy and to use the networking resources. So if your functions administrator is not part of a tenancy administrator groups, you have to add these policies in the compartment. there are a lot of information about how you can fine-grain configure security policies for your functions. So the documentation for the OCI functions is very, very well written, and you will get a lot of information about these policies that you have to create in order to use the OCI functions effectively and in a secure fashion. Another cool feature that I can mention is that you can add functions. I mean, all the services of type functions, all the resources of type functions to a dynamic group. And this dynamic group, using again a security policy, can be allowed to execute different operations within your tenancy. So for example, you don't have to configure an API account with public-private keys and configure that in your function code in order to call OCI services from within a function. So you can just create a dynamic group that will hold all the resources of type FN functions, of the resources of type functions, and create a security policy to allow this dynamic group that you defined previously to perform different action. Here is a very, very relaxed security policy that allows this dynamic group to manage all the resources in the tenancy. But of course, I can refine this. So for example, I can create multiple security policies that will refine this access. So for example, the functions are allowed only to manage the compute resources or database resources or different other resources, and I can combine this with tags. And like I said, I have full control over what members of dynamic group, in this case my functions, are able to do in the tenancy. And I saw this that I added this slide into the presentation because I saw in many blogs that are describing how you can use OCI functions to integrate with different services. This part is never mentioned. So, okay, you are instructed to create a resource principal access in the function, but you are never told how to do that using, let's say, OCI console or different other tools. So basically, there are two steps. First, you have to create a dynamic group, and after that, to create the policy that allows that dynamic group to execute different OCI REST calls against different services. So I was telling you before that I will show you using a nice chart how you can interact with the functions. So you have as the main tool to create and deploy a function, the command line interface from FN project. So you can use FN project to create the skeleton for your function. You can use it to configure the context for a function to be deployed and executed. And of course, you can use it to invoke directly a function. So if you are using, for example, a FN init command, that command will generate the skeleton function for your skeleton code for your function, and you can enrich that. Together with a couple of other files, we have a function deployment descriptor. It's this YAML file, and also there is another file. It's called requirements.txt, for example, for Python, in which you are listing what other libraries do you want to add to your project, to your image. What other libraries are you using in your code? Once you have this, using the deploy command, you can create the image for your function and deploy it to the registry, to the OCI registry. And once you have that image in the registry, you can go to the next step and invoke that function. So you can invoke it using different ways. You can invoke it directly. And what's happening then? The image is pulled from the Oracle registry. The container is created, and the function is, like I said, it's executed within a container. We have multiple instances that are executing multiple container. Everything is scalable. So if you have a large number of requests for your function, you can scale up to, if I remember correctly, 60 gigabytes of memory allocated to your function across an availability domain in OCI. So you have these containers that are running your function images, and from that you can access different other services. So, for example, you can access the PaaS or SaaS or IaaS services that are available in Oracle Cloud. You can have Oracle Cloud Services. You can call Oracle Cloud Services. Like I said, you have access to the shared services, and you can access, for example, private resources if you configured your function application with the right subnets to access those private resources. Now, like I said, OCI function is the glue that can be used to connect different services. You can use it to connect SaaS applications, PaaS applications, and infrastructure as a service applications, all using simple code and tools that are available as part of the service. So let me show you actually how this works, because it's a very cool service, a cool tool that you can use to integrate your services. So first, I will show you my development environment. So what I did, I have I'm not running this IDE on my machine. Actually, the IDE Visual Studio Code is running on my machine, but the files that you see here are available on a server that I have in OCI, in a VM that I have in OCI. And I'm using this very cool extension of the Visual Studio Code. It's called Remote Explorer. And using Remote Explorer, I can connect to a machine that I have in a cloud using SSH protocol, and I can work on that machine like I'm working on my computer. That's useful because you can create your development environment very fast, very easy. And for example, if you don't have access to some tools on your machine, you can deploy them on a VM and use them from there. So, for example, I'm connected to that dev machine that I have in a tenancy in OCI, and I can work there like I'm working locally on my machine. So this is my OPC directory, home OPC directory, and here are my functions examples. So in console, in OCI console, if you're looking for functions, you can go directly to functions application, and we have a new service that is available. It's called pre-built functions. So these are functions that are pre-built and ready to be executed, so you don't have to build your functions. There are some already created functions that you can configure and you can use. But let's go to the application. Let's see how we can create a function, the function application, the hardware, an application and the function, the hard way using code. So I already have an application created with all my examples. So I have a number of functions here. Those functions I'm going to use those for demos. These are examples that are ranging from sending notifications using OCI notification service to writing the files in the object storage using email delivery service, controlling a compute instance, reading all the parameters that are received during the function invocation, and so on. And of course, I have some very simple hello services, hello world services. Now, if you want to create a new application, just go and click on create application, and you have to provide a name for your applications. Let's call it demo 1. You have to provide the virtual cloud network. In this case, it's VCN1, and you can select up to 3 subnets. So in this case, I have 2 subnets in my VCN, public and private, and I can use that. And if I click in create, that will create a new application in a new function application. But I don't have to do that because I already have one and I can use it. once you have your application, you can start building your functions. And what's very, very cool is that you have all the tools available here. So, for example, if you are going to getting started, you have instructions about how you can build, how you can start with your function. So you have two options. You can either go with the cloud shell setup. So this is the tool that is available from the developer tools, or you can go with a local setup in which you will have to deploy a couple of tools on your machine, the machine that you are using to build OCI functions, to build and deploy OCI functions. You will have to deploy the FN CLI, you will have to deploy the OCI CLI. But anyway, you will have that. You will need that in the future. You can, if you need that, if you will need that in the future, you can go with local setup. But like I said, the easiest way is to go with the cloud shell setup. I will use the local setup. And here are some commands that you have to execute in order to create your functions. So first, you will use the fn init to create the skeleton for your function. You will check after that what was generated for you. You will create a context. So every function application is integrated with a context. And in this case, the name of the context is the name of the container in which I'm creating the function. And I already have this because I already created some functions in this application. But anyway, you can generate a different one if you want, and you will have to add some parameters in the context, like the compartment ID and the API URL for the functions. And you have all this information available from the console. You don't have to go, for example, to the documentation to look for this. After that, you will have to specify the registry that you will use for your function. Log into your registry, and the last step will be deploying your application, deploying your function within the application. In this case, my application name is demo. And I can deploy my function here and invoke it using again the FN CLI tools. So if you want to do this, like I said, you just have to copy the instructions from here. So I'm in the context of I'm in a directory in which I have other functions, and if I'm trying to create a new function, I will choose my runtime. For example, Python is the easiest one. And the name of the function will be function1. So if I execute this, I executed this command, and I will see a directory here, function1 should be also here. And here, there are the three files, the skeleton for my function. So I have my Python code. I have the function deployment descriptor. I have the requirements. So here I can add different libraries that I want to use. So for example, requests to make HTTP calls, or OCI to make calls against OCI services. So next step, I can just deploy this function and execute it. So I have to go in the function directory here, and the command for the deploy is also mentioned here, fn deploy, and in which application I want to deploy my function. And as you can see, what's happening behind the scene, a Docker file is created, and an image is created using that Docker file. So I have a base image for my Python for running functions executed in Python. An image is created. That image is pushed into the repository. So I have a OCI registry in my OCI registry, I have this function available in this repository. Now, of course, I can invoke the function, but I will show you something that I did not mention in the documentation. A very important part, logging part. So you can configure logging for your function. So all the function execution is logged, and you can use for that the OCI logging. So OCI logging service. So you just have to enable the log for OCI functions, provide the log group and the log name, and all those informations are going to be logged in the OCI logging service. But there is a delay between you are executing a function and getting the log information, because as you can see in the function code, you have a lot of logging statements. So you are writing out the data in the using these logging statements. Those are going directly into the log. What I want to say is that you have the option to configure a syslogger, and this syslogger is actually a very simple application. It's actually a socket. It's an address and the port, and you are sending data. If you are configuring a syslogger for your application, you can choose to send data to a socket, and that data is automatically registered during your function invocation, and you can check those logging information there. And there are different solutions. So for example, there is a tool called Paper Trail for that. And also what you can do is just write your very simple logger. So what you need is a server that is listening on this address and this port and writes data to, let's say, standard output. And this is exactly what I did. So I have a very simple application. It's called Simple Syslogger. It's a Golang application that is listening on that address and the port, and it's just writing what it receives to system out. So in order to execute my function, I will have to start my syslogger first. So I have another terminal window here, and I'm executing this simple syslogger. And back to my function one, I can execute my application, and I will do that with fn invoke. And I have to specify the name of the application and the name of the function, which is function one. It will take a while because now what is happening? The image is pulled from the registry, and the container is created. And after that, the function is executed in the container, and I will get the response back. Okay, so I got the response back, and if I'm going into the logger, I see all this information, all the logging information. So what happened actually? There was an issue that the function was expecting a JSON payload from the data. Nothing was received in form of a JSON, and an error was logged, and the response was sent back. But before that, there were some logging information. So if you, like I said, if you want to check the logs that are generating during your function execution, you can use this approach instead of going to the OCI logging services. It's recommended for production because you will want to see production for functions that you have in productions logs in a safe repository. But when you are building your functions, you need something fast for debugging. And I discovered that this is a very fast way to debug your functions code. Now, if, for example, I want now to use some input for my function, I can just invoke it with a payload, and I can use the recommended approach. I'm using the pipe into the function, into the fn invoke command. So I sim echo, build a nice JSON. think that it will complain about different codes. Okay, 5 into fn invoke demo and function. Okay, the response of the function. Function 1. Okay, so the response that I received was hello Oracle, and if I'm going to my logger now, I don't see that error message, error parsing the JSON payload. Now in the data attribute, I have a nice payload. Okay, so this is the simplest example of running functions in OCI. You don't have to do anything. You just execute the code that you are getting. Now I want to show you some more complex examples that you can use. So, for example, we can take a look at this one. It's called HTTP params Python, and this again it's a function that displays the data that it receives in the response, but also it's using the logging service to display different parameters that and context informations that we have for the function. Because for an application, we can have configuration parameters, and we can have configuration parameters for each individual function. So we can define configuration parameters identified by keys and values, and in the code of the function we can access those parameters. But for functions, if, for example, we are invoking those functions using the HTTP, we can get the parameters that are available in the header. We can get the parameters that are available in the request, parameters in the request, question mark param1 equal value 1, and use those parameters in the function code. And we have many other information available. So, for example, we can get information about method that was used for the request. We can get information like the application ID, that is the ID of the application to which this function belongs, the function ID, the call ID, the format of the call, deadline for function execution, so how much the function, after what interval of time the function will be stopped, and different other information. So all these parameters are available from the context of your function and from your application, and also from the request. And what we can do with this, we can integrate this function with a different service. So let's say we want to use the API gateway. So we have the API gateway service available in Oracle, and you can create a gateway for your APIs. So I already created one. So what this is exposing a public endpoint for different APIs, and you can deploy your APIs within this service. And for each deployment, you can have different you can have different routes that are calling different services. But for this API gateway, instead of having a route to a backend of type HTTP, I can have this Oracle function response. So my API gateway can call directly an Oracle function. So you don't have to use the HTTP endpoint for your function, but you can integrate this Oracle function directly. And here you have just to specify the application that it's used for the function and the function name. So we already have this here. So for example, the API gateway, the path for the function is called function1. The method is post, it's calling an Oracle function, and of course you have a lot of other parameters that you can configure. For example, the cross-origin resource sharing, the header validation, query parameter validation, body validations. You can use TLS you can enable mutual TLS for your calls and so on. But like I said, this is just a very simple example that will send the request directly to a function, and let's try it. So this is the endpoint for my gateway, for my API gateway, and the path, the route is function 1 from the root. And if I'm using, for example, Postman, I have an example here. Hello world. Coaching, and like I said, I can add different parameters in the request. Sending this. Let me double check if I have the syslogger after running. Let me restart it because sometimes it's getting timeouts. So if I'm calling now this function, I will call it via this API gateway. And as you can see, I got the response back and all those parameters. So for example, the headers from the request, which are identifying the user agent, in this case, my Postman, content type, date, FN call ID, all these parameters are available from the header. Configuration of my function, the FN application name, FN application ID, all this information is available here. The query string parameters that I mentioned, the param1 and the param2, and of course the body, it's a JSON now, and it's correctly formatted. All this information are available in the function for during my execution. So if I want to build something more complex with this, I can use it. So I can use an API gateway to send the requests from different services. For example, monitoring services to the same function, and I can use the request parameter to differentiate between sources of those messages. I don't have to rely on the body of the message of this request body to differentiate between sources from which I'm getting the message. So this is a very cool way to integrate with OCI functions, and you can do that directly from the gateway. Now, another cool feature is the event rules. Event, service, and the rules. And as you probably know, all the services in OCI are raising events. So for example, when a VM is created, we have an event that identifies that. When an object storage bucket is created, again, we have an event that is doing exactly that. So that is saying that. So we have now a tool to integrate these events, to listen for those events and send notifications to different third parties. So for example, to Splunk or to ServiceNow or to different other applications. Even more, for example, when a VM is created, we can check that the VM parameters, so for example, for tags, and if the VM doesn't have the right tags, we can directly from a function, we can stop that VM, or we can even delete that VM. We have all the control that we need within functions using OCI services. So for example, for a demo function, for a demo rule, we can say that the condition can be an event type. We can select one of the service that is available. We have access to the events generated by all the services. So compute, when auto-scaling starts, when a boot volume is attached, when a container instance container creates, begins, or ends, or when image is created, or when an instance is created or deleted. So we have access to all these events within the event rules. Let's use something easier to demonstrate, because starting a VM will take time and we have only 2 more minutes. Let's use the object storage. Object storage, and let's say bucket create, and the action can be one of the following: streaming. I can send data on an OCI stream, I can send a notification, a message on a notification topic, or I can call directly a function. So for what what I need, I can select the function, and for that I have to find my compartment, which is in this very popular tenancy, fsana operations, if I remember correctly, fsana.throw operations, and I have here my demo function. I can use this HTTP param function, and now I just create the rule, and when a bucket is created, so when a bucket is created in here, I can see something, I can see my function being executed. So let me check this. It works. And let's create a bucket. Compute object storage buckets, open link in the new tab. Bucket. Create. And should see something here. It's lost between all the other messages. Let's do like this. Anyway, until we are waiting for the message here, we can, for example, check in our application, for example, in the metrics section for the functions that have been for the function, the monitoring numbers. So where is my HTTP params Python? It's here. If I'm going into the metrics, I can see how many times my function was executed, and you can see here is my function executed exactly on the hour when my bucket was created, and that's one way to integrate with. Yeah, let's see. Here is the data that is coming from the logging in the function, and let's go to other services that we can use to integrate. Let's say monitoring, alarms. We can go to alarms, and we can go to alarm definitions, and we can say, let's create an alarm in the same compartment in operations, and let's call it demo alarm, and we can set different parameters like severity and the body of the alarm. We can put some messages here. We can add some tags, and now we have to specify the metrics that we want to follow. So in my compartment operations, I can select the metric namespace. This is related to the services that I have in the compartment. I don't have any compute. I have some PCNs, but let's use our function as a service metrics, and we can select, for example, the function execution duration or function invocation count, function response count, and I can say that if we have a function invocation over 1 minute, the mean number of function invocations over 1 minute over a certain value, let's say 2, trigger an alarm with a delay of 1 minute. Okay, we have an alarm. What we can do with it? We can send it to a destination, and this destination can be a notification. A notification. For the notification, we have to specify a compartment and a topic. So let's go to the notification, and we have a demo topic. We have this alarm created. Let's save this alarm, and let's go to the notification. And okay, if we are searching for the notification, integration notification, we have in operations compartment this demo topic, and we can define one or more subscription. One subscription is of type email, but we can create another one. Let's say subscription of type function, and here we are again selecting the functions for which to which we want to send this this notification, and of course we have access to the notification payload to the JSON, and we created this this notification. So now, if in the next minute the number of invocation for functions in that compartment will be over 1, we are going to get this this alarm, and this alarm will send a notification. This alarm will send a message to a notification service topic, and that notification service topic has a subscription of type function that will call another function. So it's a cycle. That's another way to integrate with functions. There are other ways. So, for example, for logging, if we are using the logging service, we have this service connector, and this service connector can integrate different sources of logging. So, for example, services that are generating logging messages, let's say VCN flow logs that is tracking the flow of information within a VCN. We can create this service connector test and in the compartment, and for that we can select the source that can be logging, and the target in this case can be a function. So I can send all the logging messages received, for example, from a log source. So let's do that for our VCN, and I will finish in after this. Virtual cloud networks, VCN, subnets. Let's say public subnet, logs, and enable flow logs. In operations, log name will be public. Okay, so my public all log will be enabled, and it's being created. And I can go to the service connector now. And say that I want all the logs from this default group, public all for my subnet, flow log for my subnet, to go to the function, or in this case the target. It's a function, and it's function 1, let's say, but I can configure an intermediate target. So flow logs first are sent to this task. Data is refined and it's enriched with data from other sources, and after that are sent to my target. So this is a very cool way to enrich your log data, to filter your log data before it's sent to a different to a destination, to, let's say, Splunk. Okay, this is what I had. Like I said, there are many cool use cases for functions. If you have any questions, I'm available now. Sorry, I went a bit over time, but yeah, I
no worries, Flavius. No worries. We have 2 questions that you can answer, of course. One is coming from Marius, and he is asking this: do concurrent requests require dedicated containers, or can they use one container?
For each request, we are having a different container. So, one more second. Yeah, for each individual request, we are using a different container. So we can create containers for all the requests that are coming from the functions, and we can scale the number of containers until we reach the maximum of memory allocated for the region.
And one more
for the region, yes.
Can the images be stored in external registry, or the OCR is the only one supported?
You can configure your own I don't want to say stupid thing here. Let me check. I know that the Oracle registry is available. I don't know if you can configure a different one. Just drop me an email on that, and I will check and get back to you with an answer.
All right. Good. Thank you, Flavius. I don't see any other questions coming. So with that, I would like to thank you all for being here with us today, for staying until the end. Thank you, Flavius, for this great session and demos. We hope to see you again soon. Enjoy the rest of the day, and see you soon. Thank you. Bye-bye.
Thank you.